All right, 2.3.2, the quotient rule. So in our pre-activity, we learned that if we wanted to find the derivative of a quotient, we could not just take the derivative of the top and divide it by the derivative of the bottom. That won't work, right? That doesn't give us the correct answer that we found by distributing. So we have to do a little manipulation here. We're going to use what we already know about the product rule, and we're going to try to apply that to this thing. Because remember, a quotient is just an inverse operation to multiplication or to a product. So they're actually really closely linked together. So we're going to try to use the product rule to figure out the quotient rule. Before we do that, there's a couple stipulations that we have to have. F and G, the top and the bottom, both need to be differentiable functions, meaning I need to be able to find the derivative of the top and the derivative of the bottom. And then also G of x, or the bottom, cannot be equal to 0. Because if G of x equals 0, then this whole thing is undefined. And if it's undefined, we can't find the derivative of it. Right? So let's take what we know, and let's pretend that we're just doing an algebra 1 equation. Right? So if I were trying to manipulate this function, what I would do, we're going to find q of x, q prime of x. Anyway, if I wanted to manipulate this function a little bit, I would multiply both sides by g of x. So I'm going to multiply this side and this side by g of x. So I got f of x equals q of x times g of x. And the reason why I did that is because now I can do the multiplication rule here to find f prime, q prime, and g prime. So let's do the multiplication rule, right? So I got f prime of x equals, leave the first alone, times the derivative of the second, plus the second times the derivative of the first. And now I need to get q of x alone. So what I'm going to do is I'm going to get all this stuff right here over to the other side. So I'm going to subtract qx times g prime of x from both sides. So I get this thing right here, this function right here. I'm almost there. I need to divide both sides by g of x, which I did right there. Hopefully you can see that. There it is. I'm going to divide both sides by g of x. So the only weird thing that I still have here is I still have a q of x in my top. I want to get the whole right side in terms of f and g, right? So this q is still an issue. Which brings us to, too far, our next step here. So I can rewrite q, remember q, this is really clever. I can rewrite q as f of x over g of x. So that's what I did here. And now I'm going to multiply, I'm trying to get the g of x out of the denominator here. So I'm going to multiply both by g of x. Let's put my little face right here. And that leaves us with this right here. Q prime of x equals g of x times f prime of x minus f of x times g prime of x over g of x squared. I know what you're thinking. Do we have to memorize that? There's a nice little rhyme that we're going to teach you in a second. You'll never forget it. It's one of the easier things we do in here. So the quotient rule. The quotient rule, assuming that f and g are differentiable functions, and their quotient equals q of x equals f of x over g of x, assuming that is also a differentiable function where g of x doesn't equal 0 like we talked about, q of x is going to equal this thing right here. So I'll give you a second to write that down. You can pause the video, give that a jot down. You're going to need it, right? So you have the product rule now. Well, we have the power rule. We have the derivative of sine and cosine. And now we have the product rule, and then finally the quotient rule, right? There's a great little saying, though, that's going to help you remember this. So if you think about it, G is the low, and F is the high, right? So this is going to be low D high minus high D low over low squared, and you're good to go. So it's low D high, low, times the derivative of the high, minus high times the derivative of the low over low squared, and you're good to go. Low D high minus high D low. Another way to think about it is you can go low D high minus high D low over low low. I've seen that from time to time as well. Right? So this is going to be kind of the basic way that we find these derivatives. Let's do a quick example. So let's say q of t equals the sine of t over 2 to the t. So you can't just do the derivative of the top over the derivative of the bottom. What we have to do is we have to use our quotient rule. So I went low times d high, derivative of sine is cosine, minus high, sine tx. D low, derivative of 2 to the t, is itself 2 to the t times the natural log of the base over low squared, or over low, however you want to think about it. Clean that up a little bit. Q prime of t equals low d high minus high d low over low squared. One more thing. Oh, hopefully that goes away. Actually, I don't know if you can see that. There we go. Oh, you can't see it. Let me bring this down a little bit. Be patient. There you go. So we got, yep, you can see in this step, both the t's, both this part of the equation and this part of the equation have 2 to the t. So I factored 2 to the t out. I have 1 2 to the t up top. I have 2 2 to the t's on the bottom, so I can go ahead and simplify those. This goes away, the squared goes away, and I'm left with cosine of t minus sine of t ln 2 over 2 to the t. Yeah, and that's it. High d low d high minus high d low over low, or low d high minus high d low over low squared, and you're good to go. Peace.